Assalamu alaikum friends. Today we will explain problem number 6.1, that is water is flowing through a pipe of 5 cm diameter, means the diameter of a pipe is 5 cm under a pressure of 29.43 Newton per centimeter square, and the pressure is 29.43 Newton per centimeter square, means we have to convert it into Newton per meter square, and we have to convert the 5 centimeter into 5 meter square into SI units, and this is the gauge pressure, and with the mean velocity of 2, the velocity is 2. Find the total head and total energy per unit weight of the water at a cross section. We have to find the total head or the total energy per unit weight, that is the one side of the Bernoulli equation, which is 5 meter above the datum line. We can suppose datum line or choose it anywhere. We can put it at the bottom, at the mid, at the top, but the more convenient it that we put it at the base, so it would be 5 meter above the datum line. How we will solve? Here the diameter of the pipe in the given, all the data if you see has been converted into the SI units. Now we are required with the total head, so total head is the pressure head plus kinetic head plus datum head. We will pressure head is P by rho g. Rho is the density of water is 1000 kg, that is given here, rho 1000 kg per meter cube, and kinetic head is v square by 2g, that is means you can easily compute it, and by adding them we get 35.204 meter answer. Similarly, problem number 6.2, if we see a pipe through which water is flowing is having diameter 20 cm and 10 cm at the cross section 1 and 2 respectively, means there is a pipe and here the cross section is 20 cm, and after a while here at point 2 it is 10 cm. So the velocity of water at section 1 is given 4 meter per second. Here the velocity is 40 meter per second, and find the velocity head at section A and 2 and also rate of discharge. We have to find the rate of discharge, means the Q, and also find the velocity head. We have to find the velocity head, means here the velocity is given, here we have to find the velocity. So what would be our strategy? First of all, we would convert all the units into SI units. This is being converted into meter, here meter by second, here meter square, and we will transform the diameter into area. We can convert diameter into area by multiplying pi by 4 d1 square, means if we have a diameter d1, so the area would be pi by 4 d1 square, and here it is. Similarly, if we have d2.1, so area 2 will be pi by 4.1 square, that is 0.00785 meter square. So the velocity head at section A, we have v square by 2g, so putting the corresponding values we will have at point A, but we don't have velocity at point 2. So what will we do? We will apply continuity equation, that is a1v1 is equal to a2v2, means area into velocity at point 1 would be equal to area into velocity at point 2. The product of area and velocity would always be same, so by this equation we can compute the v2 value with respect to v1. So we have v1 is given, a1 is given, a2 is given, we can find v2 as 16 meter per second. So finding the velocity head, then we will have v2 square by 2g, and here we will have the value would come out to be 13.04, 83 here calculation, there is a mistake in the calculation. And how we will find the discharge? That is, at any point you will have to multiply a1 by v1. So multiplying a1 by v1, we will have the rate of discharge, that is 125 liters per second. And how meter cube per second has been converted to liter per second? That is, if you multiply 1000 with meter cube per second, it will be converted into liters per second. And that is all that I knew. And here this first thing that they have asked was the head. So the velocity head is 0.815 and rate of discharge 125.6 liters per second. Thank you very much for watching. Keep watching and stay tuned. We will be back soon.